All right, so here's an example of shear flow and the shear stress in a built-up beam. So we have this beam here, A, B, C, and we're supposed to determine the shear force in each fastener for the system, and the bolts are spaced at 5 inches on center. So each bolt is 5 inches on center, and remember how we talked about in class, one way to think about this is we're thinking about each bolt has to carry the force from the in between the middle of two bolts. So this is also S. So the equations we'll be using here are that our horizontal force, let me do this in blue, equals the shear flow times the spacing. And then we have that this is the force that the bolt can hold. And then we have that shear flow, Q, equals the shear force in the beam times big Q, and that's that the first moment of the area that we all like to calculate, all over the moment of the inertia, which is always the moment of inertia of the whole cross section. So then we can write the force, the horizontal force each bolt needs to carry is the shear force in the beam times big Q, first moment of the area, all over moment of inertia times the spacing of the bolt. Okay, so we know the bolt spacing. We can calculate I. We can calculate Q, and we get V from the shear diagram. So that's what we're going to do first. So we will determine V. So we'll start by drawing a free body diagram of this beam. And we have to solve for the reactions. So we have a 500-pound load at the end. Then here in the middle, we have a reaction at B. And then here at A, we have a reaction at A. And each of those forces are 7 feet apart. So then we're going to solve for the reactions. We're going to start by summing the moment around B. And that equals 0. And that equals a negative, the RA makes a negative moment times 7 feet. And then the 500 also makes a negative moment times 7 feet. So that's 500 times 7 feet. And we get RA equals a negative 500 pounds. So it's actually pointed down. Okay, then we're going to sum forces in the Y. That equals 0, equals RA, which is negative 500, plus RB minus 500 pounds, and we get RB equals 1,000 pounds. Okay, so now that we know that, we can draw a shear diagram. So our shear diagram is going to go, oops, sorry, wrong way. It goes down 500. RA jumps down 500. Then nothing happens until we get to RB. Then it jumps up by 1,000, so we end up at, so this is negative 500 pounds. This is the shear diagram. Now we jump by 1,000, so we end up at a positive 500 pounds. Nothing happens. Then when we get to the end, it jumps down by 500 pounds and we close. Okay, so that means that our shear throughout the beam equals a positive or a negative 500 pounds. Okay, so next step, so now we know Q or V, now we're going to calculate Q. So Q, I'm going to make this, so what I'm doing now is calculating Q, and Q equals the sum of the yi's times the ai's, and that also just equals y bar a. Y bar is centroid of the whole thing to centroid of the area that we're considering. So the area I'm going to look at is right here, this top block. Okay, so to find y, I have Q equals, I have really gotten fond of this going all the way up to the top, so that would be 3.5 inches. And then going to the centroid of this area, which would be half of the 2 inches. So minus 2/2 inches, or 1. So that is all y. Then we take it times the area. So that's 8 inches times 2 inches. So that's the area. And when we calculate that, we get Q equals 40 inches cubed. All right, so that's Q. Then we need to calculate I. So here we're going to have 2 parts. We have part 1 down here, part 2 here. I'm not going to make a table, I'm just going to do I equals the sum of I bar I plus AI DI squared. Okay, so here I bar 1, that's this one, so B is 2, H is 8. We have that this is 2 times 8 cubed all over 12, plus the area is 2 times 8 times D is the distance between the centroid of the whole of part 1 is at 4 inches, so it's half of 8. So half of 8. And then we have D1 is this distance. Sorry, not DI. This is D1. It's this distance. So that is 2.5 inches, and we square that. And then we add the second part. And so plus, now the base is 8. The height is 2. We cube that. Put it over 12. The area is the same. Oops, not equals. Plus 2 times 8. Now we have the centroid here to the centroid here, which we calculated this was y up above. So that's 2.5 squared. So we get I equals 290.7 inches to the 4th. All right, so now we go back to our equation. We calculated V, Q, and I. We were given the spacing, so now we can calculate the force per bolt. So this equals FH equals that VQ over I times S V has a magnitude of 500 pounds. It's either positive or negative, so 500 pounds. Q is 40 inches cubed. I is 290.7 inches to the 4th, and the spacing is 5 inches on center. Is 5 inches. So we get a force in the horizontal equals 343 pounds per bolt. That's how much each bolt needs to hold.